Hello everyone, so today we will be going through some questions on how to count the number of particles in atoms, ions and isotopes. Okay, so I hope you have already tried this worksheet and downloaded it. So let's look at question number 1. So question number 1, we are given a list of particles as well as like the number of protons, neutrons and electrons for each particle, and we are asked to identify certain things. So in this type of question, we must remember that we must focus our attention on the number of protons, because the number of protons will give you the identity of the element. Okay, so let's look at the first one. From the table above, choose the element that represents a neutral atom. So that's first one, neutral atom of a metal. Okay, so a metal belongs to either group 1, 2 or 3, or somewhere in your periodic table. So when it's from group 1, 2 or 3, that means that the number of valence electrons has to be either 1, 2 or 3. Okay, next it has to be a neutral atom. Neutral atom means that the number of protons must be equal to the number of electrons. So let's look at the table on top. A is not a neutral atom, right? B, we have 11 protons and 10, that's not neutral. C is neutral. Okay, so let's first write out the electron arrangement for C. So that's 2.8.2 because I have 12 protons and neutral, so 12 electrons. So that is group 2, right? So that's a metal. Right, let's look at the next one, D, 17. So 17 is neutral, 17 neutral, so 2.8.7. So group 7, that is not a metal. Let's look at the next one, 10, 10, neutral, 17, 17, neutral. So 10 is 2.8 and 2.8.7. Now, you may be wondering, why am I writing the electronic configuration using the protons? Right? So the reason why is because I'm trying to write the electronic configuration of the atom. And as you can see over here, B and A, they are not atoms because the number of protons is not equal to the number of electrons. So we need to look at the protons, focus on the protons over here. Alright, so over here, which is an element that represents a neutral atom of a metal. So over here we have the answer C. Okay, it's neutral and it's from group 2. Next, it's an element from group 0. So group 0 is the last group on the periodic table and it always has a full valence shell of electrons. So now let's look at it again. All right, so we have A, it's 2.7 and this 2.8.1. So looking at all of this, which one has a full valence shell of electrons? So A, B, C, and D doesn't have a full valence shell, and F doesn't have a full valence shell. The only one that has a full valence shell will be E, and therefore this is an element from group 0. Next, cation. So please remember cation, T, there's a T there. So cation is a positive ion, meaning the number of P is more than E. So let's take a look at all of them, and we can see that B has more P than E's, more protons than electrons, and that's it. Right? Anion, N for negative, so there's more electrons than protons. So let's take a look. More electrons than protons, that would be A. Right? It has 10 electrons and 9 protons. Last one, pair of isotopes. So please recall, what's the definition of an isotope? Isotope is atoms of the same element with the same number of protons and a different number of neutrons. So same number of protons, so immediately I can zoom in on D and F. And do they have a different number of neutrons? Yes, so pair of isotopes D and F. Alright, let's look at the next question. The electronic configuration of an ion, take note, an ion, M, is 2.8.8. So this is the electronic configuration of the ion, not the atom. Okay, so the number of neutrons in M is 21. What is the nucleon number of N? Nucleon number is P plus N, and we want to find out what is this. The number of neutrons is 21. So I is P plus 21, and you want to find this. Now I need to find the number of protons. How do I find the number of protons? Right? We know that in an atom, the number of protons is equal to the number of electrons. However, we do not know how many electrons are there in the atom because we are only given the ion. However, from the ion we can tell. Currently, the ion has a total of 18 electrons. And this ion is 3+. 3+ means that there must be 3 more protons than electrons, right? Because it's an overall 3 positive charge. 3 more protons than electrons. And if there are 18 electrons, the number of protons must be a 21. 21 positive charges, 18 negative charges, so therefore a total of 3 overall positive charge. Alright, so if I have 21 protons, right, and if I have 21 neutrons, the total nucleon number is therefore 42. So this answer here would be D. Okay, so this question is actually quite interesting, quite challenging. So please take a good look and see where, make sure you understand how is it done. Okay, the last question, this graph over here. So we need to understand this graph. Graph 1 and graph 2 have different axes. One is relative mass, one is relative charge. So if you look, how we read this graph is that if you look at particle A has a mass of 2 and a charge of +2. Okay, so we are going to find which particle refers to electron. Now, electron has almost 1/1840 mass, right? And it has a charge of -1. So let's find which particle would that be. So you can see particle B has almost 0 mass and it has a charge of -1. So particle B is an electron. You got that? Okay, let me change color. Which particle could represent the nucleus of a helium atom? So please check your periodic table. You will have noticed that helium is like this. That means that helium will contain 2 protons and 2 neutrons. 2 protons and 2 neutrons means that it has a mass of 4, right? So it can either be here, D or E. It has 2 protons, that means it's a 2+ charge. 2 neutrons is 0, so the overall charge of the nucleus is +2. So if you look at D has a mass of 4 and a charge of +2. So that's okay, that's good, right? If E, we have a mass of 4 but a charge of 0, so this is wrong. Okay, so over here, the answer here would be D. Okay, lastly, which 2 particles, right, would represent a nuclei of isotopes? Nuclei is the plural of nucleus. So isotopes must have the same number of protons, right, but different number of neutrons. That means the nucleus must have the same charge because it has the same protons. So they must have the same charge. But different number of neutrons means it will have different mass. So let's take a look. Which 2 particles here have the same charge but different mass? So by looking over here, A and D has the same charge, right? And A and D have different mass. So that's great. So A and D are isotopes, and we need to write the number of subatomic particles present. So let's look at A. A has a +2 charge over here. +2 means in order to be +2, it must have 2 protons. Right? It already has 2 protons, so the mass is already 2. So if you look here, A also have a mass of 2. That means it cannot have any neutrons. Right? So A has 2 protons and 0 neutrons. That is how A has a mass of 2 and a charge of +2. Let's look at D. D has a charge of also +2. That means it also must have 2 protons. That's why it's an isotope. Right? And it has a mass of 4. Okay? So because it has a mass of 4 and it only has 2 protons so far, so that means the remaining mass must be made up of 2 neutrons. Okay? So this is how you're going to answer this question. This question is really very interesting, and I hope you try to analyze it and see whether you can understand. Alright, continue practicing. If you have any questions, please feel free to ask your friend or ask me. Alright, all the best. Bye.